Hello guys, welcome to Math Vantage. So in this lesson we are going to talk about the tree diagram for drawing with replacement. So there are three examples that we are going to do, but then on this video I'm only going to focus on the first example, and I will do the other two videos, and there will be the other two videos for the second example and the third examples for the tree diagram. So let's start with the first one of drawing with replacement. So the question says a bag contains 6 red balls and 4 balls. A bag is chosen, the color is recorded, and the ball is placed back. You can see that it's placed back. So meaning it's drawing with what? With replacement. Therefore a ball is chosen again and the color is recorded. So therefore, what is the probability of choosing the two balls of different colors? So most of the time, to be able to solve this question, I prefer people to draw tree diagram because you can solve it without tree diagram. But then I want us to talk about how can you solve it, and also talk about how to draw a tree diagram because most of the time you might be asked to start by drawing the tree diagram. So as a ball is chosen and the color is recorded, but then we don't know which ball was chosen, right? So the first branches that we're going to give for this one, whereby the first ball was chosen and recorded, which for here we can represent it as ready, and then this one we can call it it's red and 4 balls of blue, supposed to be blue. Yeah, yes. Therefore we have blue here. So it's red and blue. So now we know that for red we have 6, right? And then for blue it's 4, right? But then what is the total number? Remember, like now we are dealing with probability, so we must write these values in terms of the probability form. So you must divide by the total number of those balls. What is the total number of those balls? It's going to be 6 plus 4, which is going to be 10, right? And to confirm your answer, whether you wrote the answer that you wrote here is correct, um, when you add these two values, you must get 1, right? So in other forms, you'll be given 6 all over 10 only, and then you should be able to get this one by doing what? Let's say you were given only 6 red balls, right? And then you are not given for this one. They said it's X. Because of you are given 6 red balls, we know that 6 over 10 we know that 6 over 10 plus all over 4 over 10, it has to give us 1, right? So if it was x, it was going to be x is equals to 1 plus 6 all over 10. So you must expect this type of questions because the examiner knows that you guys know how to solve this whenever you are given all the values. So now it might give you the one value. So if it gives you the one value, just know that you solve for x, whereby you equate everything to 1. Because when you add these two values, always you must get 1. So let's continue um, with the business of the day. So now, after writing these values, now we know that a ball is chosen and the color is recorded, right? And the ball is chosen and the ball is placed back, right? Then we did it. Therefore, a ball is chosen again and the color is recorded. Therefore, because it's chosen again, therefore we must create another branches because the ball is chosen again, right? Therefore, if the ball is chosen again, obviously here we still have red, and here we have blue, and then here we have red, and then here we have blue, right? So because of the ball is placed back, that's what we talk about drawing with placement. It means the total number of the balls, it didn't change. We're still going to have 6 all over 10, right? And then also here we're still going to have 4 all over 10. And then for here, we're also going to have 6 all over 10. And then here we're going to have 4 all over 10. Is it because of the ball, the total number of the balls, it didn't change, so that's why we write these values the way they are. In the second example, that's where we'll be doing drawing with no replacement. That's where you'll see these numbers, that these values, they do change. So now, after writing these values, what are the outcomes? From here, you can see that we have red and red, and then from here, it's red and blue, and then from here, it's blue and red, and from here, it's blue and blue, right? So these are the outcomes. So the first question say, what is the probability of choosing two balls of different colors, right? So how do we calculate this? How many different colors do we have from the outcomes? We can see, oh, this one, we don't have, these are the same colors, different colors. Here it is, different colors. We only have two. It means we need to add these two probabilities. Therefore, it means we're going to have the probability of red and blue plus the probability of blue and red, right? This is what we are going to do. Therefore, what is the probability of red and blue? What is the value of red here? We can see that the value of red, let me use different colors so that you can see it. Okay, we can see that the value of red here is what? It's 6 all over 10. Therefore, we're going to have 6 all over 10. Therefore, it's red and blue. It means we need to multiply also by blue. What is for blue? We can see that for blue, it's 4 all over 10. Plus, we do the same thing for blue. It's going to be 4 all over 10 multiplied by 6 all over 10, which is 48, right? Therefore, the final answer is going to give us, I think if I didn't make a mistake, it's going to give us 48 all over 100, right? So this is the final answer, whereby you can equate it to 12 all over 25. So this is how you find the probability of choosing two balls of different colors. So how can we find the probability? Okay, let me do this. How can we find the probability of choosing the balls of the same color? Obviously, it's going to be B into RR plus B into BB. This is the probability of choosing the two balls of the same color, right? So therefore, we are going to have, for the same color, it's going to be 6 all over and multiply by 6 all over 10 plus 4 all over 10 multiply by 4 all over 10. Therefore, that's how you're going to get your answer after calculating this. This is how we solve the tree diagram of drawing with replacement. Thank you. That's it for the today's lesson. So in the second video, we're going to talk about the drawing with no replacement. So kindly go to check that video. Don't forget to subscribe and like. Thank you.